So, good afternoon, everyone, and welcome to today's webinar, Exploring Digital Safety and Cybersecurity Challenges with Ansys. It is a webinar with Ansys guest speakers Nikhil Kelkar and Abdul Niassi, and of course, Infinite Simulation colleague Jeroen Dankelman. This webinar has a duration about maximum 1 hour and a half, and we would like to go further with you to share a screenshot of GoToWebinar introduction. And you see a screenshot of an example of GoToWebinar in the right corner. And you will have the opportunity to submit text questions and chat during this event. And at the end of the webinar, we will collect your specific questions. During the webinar, you are automatically muted. At the end, I will unmute everybody, and you can then unmute yourself if you have any specific questions or remarks. Of course, this webinar will be recorded. And the speakers for today are, of course, Nikhil Kelkar. He is Ansys responsible for France and Benelux Global Channel Sales Manager and System Business Unit. Then Ansys colleague Abdul Niassi of Ansys France and Benelux. He is Senior Functional Safety Application Engineer, and colleague Jeroen Dankelman of Infinite. He is Strategic Account Manager. The agenda for today, so we started, and the introduction by Infinite and Ansys Jeroen, then Nikhil about model-based functional safety analysis, then identifying and preparing cybersecurity threats, also by Nikhil, then the demo integrated approach functional safety analysis by Abdul, and then of course with all the questions and answers. Then I will hand over to you, Jeroen. Good luck, everybody. Enjoy.
Yeah, great. Thank you very much, Anna. Yeah, welcome again. That's introduced by Anna already. My name is Jeroen Dankelman. I'm the Strategic Account Manager within Infinite. Yeah, today we would like to introduce the Ansys Medini solution for functional safety and cybersecurity. Most important there is that, of course, is why and how and what are the main drivers for this. Yeah. If you think about why you would focus on functional safety, yeah, you can think about your business goals, most important. The how, now that's what we're going to talk about Medini Analyze for functional safety, but also, yeah, who is actually involved in this this process. That's not only, yeah, technical people, but also management, of course. So especially also as it includes cybersecurity. It's great to see such a big audience. I'm very impressed by that. And also to see that I see some familiar names. Also good to see that people are coming from all kinds of industries, which is a very good thing. Oh, we have a bit of delay, no problem. First of all, let me introduce who we are. We are Infinite Simulation Systems. We are the elite channel partner in the Benelux for Ansys. We are doing that for quite some time already, yeah? So 30 plus years. We're the solution partner based on our simulation experience, yeah, our strong technical team on all different domains from the simulation part of the world. Yeah, we provide services, we provide software, specifically on the Ansys software, and we provide training on that. Yeah, so we have a very long track record, and yeah, we are serving all kinds of industries within the Benelux. Good thing to mention is that also last year we became part of a slightly bigger group. So we also have now sister companies that focus specifically on PLM and CAD systems. So one example of that one is, for instance, GPO, who is the PTC partner within the Benelux. Also nice to mention is that our team is growing strongly. We have, yeah, lately we have several new colleagues. Yeah, so we are expanding the team in order to better support our clients and their needs. So talking about Ansys, most of you are familiar with what Ansys does. But this is exactly the reason how you can actually start to manage your functional safety and cybersecurity part on top of your various domains. Companies today are dealing with complex product challenges. They require a comprehensive simulation and analysis system to understand exactly how their product will operate in real world. That's what simulation does. Ansys has the broadest and the deepest simulation capability of the planet, spanning the physics of structures, fluids, and electromagnetics, as well as areas like semiconductors, photonics, for instance, but also, of course, functional safety. Ansys solutions are the gold standard in every industry. That's also what we do. These solutions can predict real-world product behavior because they are the most accurate. This is the result of our decades of experience in helping our customers in the various industries. So how do we do this? Ansys has a process in place integrated within the entire Ansys platform. In this way, we are focusing on the simulation and analysis process of our clients. In this way, we are able to understand and combine the physics through the software and services that we provide. So here you see the steps that include the entire process, really going from the design to ideation stage to manufacturing in product, but also in operation. And the last one is a very interesting one because the latest development there is that you can actually have a better understanding with Ansys simulation software on the predictive maintenance, for instance. You can think about if your product is used in the field, that's one of the trends these days. You can have a better understanding, do digital twin and IoT solutions of Ansys about the predictive maintenance. Another nice trend to mention is at the very early stage of your process, of your product development. So already in the conceptual phase, for instance, you can already start doing simulations. This is something that Ansys really pushes to have a better understanding, like what are the results in a very early stage of your product development. Most important in this whole approach is that we, as the Ansys partner in the Benelux, we put your business goals in the center. So how is this achieved? So the setup of this platform of Ansys is shown here by the physics blocks. So most of the people in the industry, they know us of the fluids and structures simulation capabilities, but also on the electromagnetics, for instance. One of the one that we're talking about today sits in the mission critical embedded software part. You see it highlighted here in the gray block. And within here, there is the Medini Analyze functionality. But we also have there the skate functionality, which I'll emphasize in a minute. So if we really talk about Ansys Medini, and our colleagues from Ansys are going to talk about this in a minute and really take you in depth. But most important is that Ansys Medini Analyze streamlines your functional safety analysis across the entire system architecture, including electronics, down to your chip level. That's really important. Ansys Medini Analyze is a model-based integrated tool supporting safety analysis for safety critical electronical, but also electronic and software controlled systems. It allows for consistent and efficient application of industry guidelines, specifically tailored for the industry, for various industries. So if we talk about various industries, I'm not going to go in detail, but this is to give you an idea like that Ansys Medini and the cybersecurity part can actually be used within these different industries with their different standards. Nikhil of Ansys will focus on this in a bit more in a minute. So think about your business goals. So what will happen if you going to present your product? It's almost completely developed. But if you think about your business goals, like time to market, about the risk that you have within the complete development part. So think about if something happens that you haven't seen before, like what you see in the screen here. That's a bit of an accident. So there's a huge impact within the team, of course, but also on your business development goals. So this will throw you back and give you a huge delay to actually present your latest version of the product to the market.
Jeroen?
Yeah, I'm a bit too fast, so just a second.
Yeah.
All right. Another very important part is that IBM, for instance, is doing a lot of research on the cybersecurity part as part of functional safety. So every year they come up with a top 10 of industries that are under attack of cybersecurity. You see here the list of 2019, the top 10. So starting from finance all the way down to healthcare. What I would like to show you at the end of the webinar, I'd like to show you like the top 10 of 2020. Yeah. So be patient. I will show you like how it will look like, and there's a major shift going on. Yeah. We don't have the information of 2021, but that will be available next year, of course.
Okay,
One
Jeroen.
small second. Yes, please.
Yes.
I would like to hand over to Nikhil Kelkar. He is the System Business Unit Global Channel Sales Manager. And he will talk about what functional safety and cybersecurity can actually do for your industry, like automotive, aerospace, and industry. Nikhil, it's up to you.
Thank you so much, Aaron. And it's a pleasure talking to you guys. And welcome everyone for the webinar. I see a lot of attendees, and it's a great pleasure to present to you guys the digital safety aspect of Ansys, which is and in which there is Ansys Medini part of it. So just going to take you through some of the slides, and before I move ahead, allow me to go and show to you a small video about what Ansys Medini Analyze is about. So just a second, due to some delay, I cannot.
Engineers have long relied on point tools to gauge safety requirements against industry standards. But this tends to be inefficient, time-consuming, and expensive. Now, there's a solution to reduce your functional safety analysis efforts and accelerate time to market. Ansys Medini Analyze. For functional safety analysis, engineers across multiple industries trust Ansys Medini Analyze for analysis at the concept, system, software, hardware, and even chip levels. All of your key safety analysis methods, all in a single integrated tool. Analyze different aspects of functional safety, define solutions, and ensure compliance to ISO 26262, IEC 61508, and others. To satisfy emerging safety standards, such as SOTIF and UL 4600, Ansys Medini Analyze identifies and addresses performance shortfalls that occur even in the absence of a system failure, so that design and performance both succeed in cases that go beyond functional safety analysis. Complex electronics are also vulnerable to cyber attacks. Increased software and connectivity opens the door for hackers, who gain more opportunities to infiltrate systems. Ansys Medini Analyze addresses system-level security to uncover and eliminate your weak spots, so your entire electronics architecture remains impervious to outside attacks. For leading electronic systems in automotive, aerospace, rail, and many more safety-critical industries. Get ahead of the compliance curve. Streamline your analysis efforts. Accelerate time to market. And deliver unmatched safety and security with Ansys Medini Analyze.
All right, so let me just go ahead into the next page. So as we talked about in the video, I mean, it was clearly mentioned that whatever analysis that you're doing currently can happen in one platform altogether. And that is what we are going to talk more. And our goal is to kind of ensure that the safety critical systems are designed with the state of art, which has a lot of safety. When we talk about safety, it has to go through different types of functionalities, wherein there is FUSA, when you talk about functional safety, customers have to do, our customers are looking at safety of the intended functionality, which is SOTIF. Cybersecurity also becomes a part of, and which is one of the most important key aspect in the current scenarios right now, where customer do not want their systems to be hacked by an external resource or for people. And for that, also, once this analysis are done, can be implemented into software engineering, from designing their system definition to safety and security analysis, also driving the safety requirements, designing and engineering the software side, and also doing the verification and validation of the safety requirements, to finally providing the safety case and compilation. So this is a multidisciplinary safe system that can be achieved using Ansys. Why functional safety? Currently, people are using point tools. Many customers are using Excel files, different products for doing their point analysis. Probably one customer is doing their HARA analysis into a different tool, and their FMEA analysis into another tool. However, because of that, there is a lot of manual workload on the customers, and also the traceability and the scalability becomes a big question mark. So the customer goal usually becomes that they want to have a scalable and a traceable software for doing their safety analysis with a lot of time saving, and are able to maintain and develop a supported solution. Ansys Medini provides a model-based approach wherein you can update your safety analysis after changing the system design or the system model, and it provides a one platform for doing all your safety methodologies required by the safety standard. Eventually, when you're using one platform at the same time, it saves a lot of time, because the reuse of work of the tool and also the guided safety management tool that has been provided by Medini reduces a lot of time benefit for the customer. So eventually the customer comes out with a saving of up to 50% on their design flows and their model-based approach. Their system analysis are compliant to the standards, the safety standards that we provide, and eventually saving money for our customers. So that's where Ansys Medini will help our customers drive their functional safety analysis goals. When you talk about software engineering, usually these analyses have to be implemented into the software engineering part, so that there is you can use those systems and design your software goals. In those scenarios, the customer needs to do and manage a lot of complexity with regards to the system software. And when you talk about automotive, they have to be compliant to ISO 262 and AUTOSAR compliant. But in the similar scenarios, when you're talking into other industry sectors, for example, aerospace, these standards have to be adhering to RN 661 or DO 178C or a phase standard, similarly for IEC 61508, and also eventually reducing their time to market. And as I mentioned, Ansys Medini, with our multidisciplinary system applications, you would be able to create automated code generation, and also verify the full model based with no back-to-back testing. So eventually saving a lot of time, confidence, and identifying the issues at a much better and a faster stage that can be done by our customers. And there would be always a reduction in the cost of change. So these are the main reasons where customer look for software engineering with Ansys as well. When you talk about Ansys safety, we cater to multiple industries. Medini was predominantly a product that was resulting for ISO 26262 standard. Eventually, with a lot of development and customer support, we've been able to work into different industry. Currently, we support IC 61508, ARP 7454A, MIL standards, ISO 21448, and the ISO 21434 standard for the cybersecurity. So if you're looking for a product collection, we have Ansys Medini Analyze, which is talking about the standard, complete standards. We also have a product for semiconductors, and Ansys Medini Analyze for cybersecurity is also the topic that we were talking in our product collection. So sorry about that. When we talk about functional safety standards, the generic standard which is derived for all other standards is IEC 61508, and from there we have been there is functional safety requirement in each and every industry right now. So if you're talking of electrical devices, the IEC standard is 618008, and Medini is supporting this standard. If you're looking into agricultural and forestry, where there are requirements for agricultural vehicles, ISO 25119 is a standard which is compliant for Medini as well. If you're coming from a medical devices industry, then you can do your Medini analysis for the IC 60601 standard. So it's in a nutshell, we are able to support functional safety standards for multiple industries, and we can dig deeper with you guys if you have a specific standard that you want to work on, and we can look into this in detail. So when you're comparing, so this slide was shared by Jeroen, and I want to get a bit deeper into it. When we talk about how can analysis be compared into different standards and different domains. So if you are working on ISO 26262, your risk graph, which is the HARA, which is the risk hazard and risk assessment, will be mentioned as HARA. But when you're talking into the ARP side, which is the aerospace domain, the same risk graph would be termed as FHA, and they would be to the DAL standard, whereas in automotive it would be to ASIL standard. Similarly, when you're talking about machineries or ISO 61508 or 13849, this would be coming into the PHS standards, which is talking about PL and SIL. Similarly, when we talk about FEMEDA, it would be into SPF. Here it would be on the talking about individual risk, and in IC it would be talking about SFF. So that is the comparison that we are going, and we are able to answer to you guys for to our customers for analyzing into different industries. I want to take across an application example. Here I'm going to talk about in-vehicle systems, which is very closer to the automotive side. However, it's going to be answering few of your questions that every customer is asking currently. And they want answers for this. So in an example, which is an in-vehicle example, the first question my customers usually try to ask me is, are all my safety analysis consistent and based on what's really implemented? That's one of the important questions. Then the second question comes across in their head is, what is the safety impact of malfunctions and failures in the systems and the component? And there are a few customers who also want to understand the impact on the semiconductor side of the overall vehicle or the system safety. And they also want to look at what are the real world scenarios where there would be capabilities of falling short. And also the biggest topic right now is cybersecurity risk based on the design. So how it's going to impact our stakeholders. So to go much deeper into that, to answer the first question, the customer is looking to have what's really implemented, and for that the customer goal is to kind of have a multi-analysis methodology in a consistent manner, and to also have a traceability and scalability of their safety analysis. And as I mentioned in my previous slides, Ansys solution provides a model-based approach that will allow you to instant update of your safety analysis even after changing the model design, as I mentioned. And it is also providing one platform, so you can do all your analysis starting from HARA, HAZOP, FMEA, FTA, and also your safety requirements. So it's a complete circle that we are able to cover with Medini Analyze, eventually reducing your time for product management. And the second question usually are our malfunctions and failures having an impact? So to ensure that our electronic systems are providing consistent performance over the time, and also how they can be maintained and developed into for a supported solution, eventually reducing the time. So biggest aspect here becomes that if there are failures, there would be delays and there would be time constraints. As I mentioned, we allow up to 50% of time saving, and that's a customer number, through early identification of the safety needs, and also so that you can incorporate those in your design flows via model-based approach. We are compliant to the safety standards, which I've already shared across into different standards, talking from ISO or being into ARP side. And eventually the main result and the benefit would be saving money with the consistent workflow, so that there would be mitigation into the tool variety. So this is one of the reasons that people are using, customers like ZF and Lithium Balance are using Medini. There are customers who want to have to see an impact at the chip level, talking into the semiconductor design. So in that scenarios, the customer designs of the mapping the semiconductor design to the functions that they support within the vehicle is of key important for the customers. And eventually the semiconductor should perform flawlessly and also have an outstanding passenger safety. So this is one of the requirements that comes across when you're talking at a chip level. And solution for that from our side is to kind of provide you an analysis that can provide you potential failure modes, and also verify the functional safety at the chip level, at the semiconductor component level, and also be able to mitigate the impact of the design weaknesses on a day-to-day safe performance, and overall providing an overall system analysis of the semiconductor side, which is integrated in the car, or in the in the system. Also, there are real-world scenarios which is also a threat, and we currently, when we are going towards autonomy, we want to have those topics also covered and considered when you talk about, say, SOTIF, which can be a bigger requirement, and which is a bigger requirement to automotive currently. How we can identify those shortfalls and also mitigate those hazards in a nominal system for automated vehicles or for the sensors in case. It should also comply to the standard which is still in a process of standardizing. So there is still time for us to do, and Ansys currently is providing a solution which is able to do systematic identification of the SOTIF risk, as well as provide a design limitation and triggering the conditions. So there is an efficient workflow that can be done on SOTIF and functional safety which is in a common environment. And these standards we are trying to be the leaders in complying to the safety standards here when it comes across sensor deficiencies in adverse weathers, or deficiencies at the driver performance. So this is where Ansys Medini comes into picture as well. And to the last topic when I want to talk is cybersecurity risk. It's one of the biggest topic. There is a video which talks about two hackers hacking a car sitting from their computer, sitting at their home, and stopping the car on the highway to kind of show that it's a very vulnerable environment right now, and that becomes an utmost important for our customers to identify these vulnerabilities and kind of estimate the impact and the feasibilities to kind of mitigate these real world threats that are currently in multiple industries, and also be able to kind of have a scalable assessment of the system limitations when you talk about. And for that, we have been able to provide our customers up to 50% of time saving by delivering specific work products, and also ensuring a transparent consistency and traceability towards the completeness, and which is a kind of a completeness of the software of the risk. And also with the functional safety, we are able to identify not just the functional safety, but also the cybersecurity issues at an early development stage to provide a consistent analysis and also resulting and creating results for the reporting side. So as I mentioned, model-based approach becomes of utmost importance for our customers when they are trying to mitigate the risk of cybersecurity. So just to talk across our customers' success stories, Ansys Medini Analyze has been applied into multiple industries. Railmill is our customer into railway side, wherein they were able to verify the safe operation for EN 50129 safety standards of the railways. And they mentioned about the model-based approach that has helped them eventually to be, and also along with Medini, they were able to work on scale together to kind of create a CBCT class automatic train control system that was on standard SIL level 4. Similarly, we have also had customers on the chip side, which is one of the most leaders into semiconductor industries, NXP. They have deployed Medini as a internal recommended tool for their quantitative safety analysis. So they are using Medini analysis for that. Lithium Balance is also a customer for us and have been using it for their battery management system, wherein they are trying to they were relying on Medini Analyze to manage and automate the process of certification for their battery management system. And also one of the biggest example that we talk about is ZF, wherein ZF used Medini to analyze and streamline and accelerate their functional safety analysis for hardware, software, and as well as on the system level. So eventually this helped them reduce up to 50% of their time devoted for this task. So eventually the time saving for ZF was up to 50%, and that was calculated with the ROIs from the customer side itself. Just a small, a bit more detail about what Lithium Balance did for their BMS design. So their challenge was that all companies supplying BMS solution to the world automaker have to be stringent towards functional safety standards, including the ISO 26262. And by leveraging Ansys Medini Analyze, Lithium Balance was able to quickly and affordably manage the verification of their BMS designs. The results here was that it helped them meet extreme demands of functional safety standards, which are a requirement of global automotive market, while also reducing their development time and the cost. So eventually it came to the main picture about time and cost here for customers. And similarly, ZF, I want to talk about cybersecurity here. With ZF, they are using our product for functional safety as well as for cybersecurity analysis. And their challenge was to provide an innovative and efficiency in its embedded system for the verification process. So we provided the functional safety tool for them, and they were able to deliver ISO 26262 work products, and also eventually their functional safety analysis were reduced by up to 50% of the time. And currently they are now applying cybersecurity analysis on their ADAS project, which is an ongoing process. So the last three of my slide is to talk about the three takeaways that if our customers are using Ansys, is that the first is that they're going to get an end-to-end product solution which would be easily traceable and compliant with the safety standard. it would provide our customers up to 50% of development time with a model-based and a safety analytical method. And also it will be able to help our customers identify the cyber attack and estimate the impacts and its feasibility in a long run. So that's my final slide for you guys. And with that, I would probably pass it on to our technical expert, Abdul Niazi, who would get you a deeper overview about the product and also run through a small demo talking about what Medini, Ansys Medini can provide you guys. Over to you, Abdul.
Yeah, thanks, Nikhil, and thanks for joining the webinar. Let's move on the functional safety with Medini. So of course, some introduction about Medini. Medini Analyze is a model-based approach. Of course, I will give you more information about how we deal with model-based in other slides. So as you can see here, we have around 250 customers using Medini on the OEM level, Tier 1 and Tier 2. As Nikhil mentioned also, Medini is used in different sectors: automotive, aerospace, railway, and industry. Of course, we have a lot of customers that they are using Medini, and according to their feedback, by using Medini, they reduce up to, let's say, 50 to 57% of time to markets. Why? Because Medini is a model-based approach. You don't need to change the tool and to do your analysis in different tools. So each activities that you need and according to standard is already in the in Medini. First of all, so all the activities in Medini. Second, that you can generate also reports from Medini. When you're done with your activities or with your safety analysis, you can directly generate safety case. And the last point that is that if and in future you want to do a changes, of course you're going to have the traceability directly in Medini. If you want to change anything, of course the changes will be propagated automatically. We have a lot of partnership with different customers. Why? Because in a company we are not going to use one tool, maybe a lot of tools at the task management side, at the engineering side. So we have a lot of partnership where we can import our requirement, our model, our analysis from Excel inside Medini. So I will give you more information in the demo how to import and the different integration that we have with different external tools. Sorry. So if you focus on the safety life cycle of ISO 26262, of course we have the concept phase. In the middle we have the product development, and at the end we have the after release for production. And when we support, of course, in Medini, if we focus on ISO, we support the concept phase where we can do our analysis according to the ISO 26262, define the item definition, we can do the hazard analysis and risk assessment, then we can do the functional safety concept, of course. For the functional safety concept, we can do a design FMEA, and of course, we support also the new standard VDA AEAG to do our design FMEA according to the standard. For the product development, of course, we do support the two phases, and the hardware part, of course, we can do also the FMEDA analysis and qualitative and quantitative analysis for the hardware part. And of course, for the software part, we can do qualitative analysis. That means you need your architecture, your software architecture, and then from this architecture, you can generate a design FMEA, and also you can do the qualitative FTA for the software part. Of course, as we mentioned, according to the ISO, if we focus on the ISO 26262, we have in Medini different work product. That means you don't need to change the tool. We have a work product or a package to do the deriving situation, hazard analysis and risk assessment, safety goal and safety requirement, function safety concept and technical safety concept, and of course, for the validation parts, we do support the FMEA, FMECA, of course, for the railway and industrial and aerospace, FMEDA, and of course, the output of the FMEDA for the automotive, where we need to calculate the single point fault and late point fault. Of course, qualitative and quantitative fault theory analysis that we can support also in Medini and dependent failure analysis that we can also support. A short demo how to create a new project here. So according to ISO 26262, part 3, section 5, we need to create the item. So here in this case, I'm Medini. I will go to create a new project. Of course, I will give a name to this project. And as you can see, we have different templates for different sectors where you can select the specific template according to your needs. And as you can see here, as we choose the ISO 26262 template, here we have the different packages. And of course, these packages is according to the ISO 26262 V cycle, where we have the item definition, hazard analysis and risk assessment, the system design, where we can create the architecture directly in Medini, or we can import the architecture from external tool. And of course, for the safety analysis, where we can do the FME analysis, qualitative and quantitative analysis, and FMEDA on the package of diagnostic coverage. Of course, this template is a proposal from our side according to the ISO or according to different standards. If you want to customize these packages according to your needs, of course, it's possible. An example, in your case, you don't want to use item definition, but maybe project definition. You can, in Medini, right-click and rename a package. Or if you have any additional packages, you can also add these packages directly inside Medini. And of course, also, if we cooperate deep down, for example, in the HARA, we have a proposal of the table where you can do the hazard analysis and risk assessment. But if you want to customize, add column, rename a column for HARA, you can also customize very easily the table inside Medini. So how we deal with the model-based approach? Of course, the input that we need is the architecture. This architecture could be at the functional level, at the subsystem level, or at the component level. And of course, the architecture that you need, you can create directly this architecture inside Medini by using the CCML language 1.4 that we support directly in Medini, because some of our customer doesn't have external tools like Magic Draw, like Rhapsody or Enterprise Architect. So they need to create the architecture directly in Medini. So that's why we support the CCML language where you can easily create your architecture. Of course, we do support to import from external tool this architecture, and I will show you in next slides. When you have your architecture, and then from this architecture, you're going to right-click, derive, for example, FMEA, then you can do your FTA analysis. Of course, you can do also the hazard analysis and risk assessment. And of course, the hazard analysis and risk assessment will help us to define the safety goal. How we use the model-based approach. Of course, for example, you have your architecture. Later on, you want to do a modification. Maybe you want to change the name of the component, the failure rate of the component, or the failure mode of the component. And of course, if this component is used in the FMEA or in the FTA, you don't need to change in different packages. you need to change directly in the architecture, and then the changes will be propagated automatically. So of course, it's a kind of SolidWorks. If you change the main view of the SolidWorks, then the changes will be propagated automatically. A short demo of the propagation, automatic propagation of changes in Medini. For example, in my case, I'm going to open the FMEA, the technical safety concept, FMEA. And of course, as you can see here we have a column where we have function or component, and I want to see where this component is located in my architecture. So with right-click, Medini show me where this component is in my architecture. As you can see, the type is 5 volt, and I want to change in 12 volt. And then if I come back to the FME, as you can see, the changes was propagated automatically. Later on, maybe I want to delete this component. And of course, if I delete this component, Medini pop up a message, be careful, if you delete this component, you're going to delete also the line that you have in the FMEA sheet. As you can see, this architecture was created directly inside Medini by using the CSML language 1.4. On the right, you have the palette, and from this palette, you can easily drag and drop and create your architecture. This slide is very important because we have a lot of integration with different tools. So as I mentioned to you, the architecture you can create directly inside Medini, or you can import from an external tool. Here we have a direct connection between Ansys Skate Architect with Magic Draw, with IBM Rhapsody, with Enterprise Architect, with MATLAB Simulink. So you can easily, without creating the architecture, if you have one of these tools, you can easily import your architecture inside Medini, and then you can do your safety analysis. Same for the requirement management. Of course, we have now a lot of integration with requirement tools. So we have an integration with JAMA, DOORS Classic, DOORS Next Generation, PTC Integrity, Rakaef, Polarian, and Codebeamer. That means you can easily, if you have your requirement, you can easily import directly your requirement inside Medini and then allocate according to the ISO, for example, allocate your requirement to your architecture, function, or component. Of course, you have also this possibility when you're doing your safety analysis, you're going to create new requirement. And of course, we have also this possibility to export requirement to the JAMA, DOORS Classic, PTC Integrity, etc. So you can also import your requirement to the external tools. Same for the Excel, because most of our customers are, before using Medini, used to do their safety analysis in an Excel sheet. So that's why we have this integration with Excel also. So if you want to import your legacy inside Medini, you can also import from Excel. That means if you have an HARA and Excel sheet and you want to import this inside Medini, of course, you have this possibility to import from Excel the HARA inside Medini by doing the mapping. We have also an integration with different point tool. For example, if you're using a tool for your FMEA, and of course, if from your FMEA tool, you can export your FMEA and MSR XML format, then we can easily also import your FMEA inside Medini because we have the integration with MSR XML standard exchange. Same for the FTA. A lot of customers using also FTA analysis, doing their FTA in the point tools. So if they can export their FTA in a Fault3 Plus or a Kafka format, then we can easily import their FTA inside Medini. For safety plan, we have also a lot of integration. for example, Jira, Bugzilla, PTC. So if our customer are using any task management tool, then we can also integrate Medini with the task management tool. At the end, of course, we have also this possibility. You're finished with your safety analysis. You want to generate a safety case. Of course, you need to do a custom report to generate the safety case from Medini. So we have also this possibility to generate safety cases by using the extension that we have in Medini BERT. Otherwise, we have also this possibility to generate standard reports from Medini. For example, if you want to generate a report for HARA or FMEA, so we can generate the report in an Excel format, Word, PDF, or HTML format. Let's move on the cybersecurity part. Of course, how we deal with the cybersecurity. The cybersecurity is the same as we have for the safety. So for the cybersecurity, we are also model-based. You need your architecture, of course. You can have a separate architecture, or maybe you can reuse the same architecture that you have at the safety side. And then you can do your cybersecurity analysis on the same architecture. So you need the architecture for the cybersecurity. And then from this architecture, of course, you're going to do the cybersecurity analysis. For example, attack trace, damage scenario, threat analysis, and then of course, when you're finished with your different activities, to define security requirement. Of course, the integration that we have for the safety part, it's also valid for the cybersecurity. That means if you have a cybersecurity requirement, an external tool, JAMA, DORS, Classic, or NG, you can also import your requirement for the cybersecurity inside Medini. And of course, from Medini, you can also export your requirement to the external tool. Same for the model. You can import your model from external tool, Magic Draw, Rhapsody, Enterprise Architect, etc. And of course, you can also generate reports in Excel format, Word document, PDF, or HTML format, also for the cybersecurity part. How we deal with the cybersecurity, how we model inside Medini, of course. We support the ISO 21434 according to the automotive, but we also support the DO 356 standard. I mean, how to do the cybersecurity analysis according to the aerospace that we can support also, and we have a specific template also for this one. First of all, as I said, you need the model. You need to create or import the architecture for the cybersecurity. Then for each component or parts, you need to define the assets, I mean the security attributes, of course. Then from there, you can generate a table where you can identify the traits. When you have your traits, then you can evaluate the risk. When you have the risk, as if the risk is very high or low, then of course the output is to define the safety, the cybersecurity goal for the automotive and for the aerospace cybersecurity requirement that we can support, and we have a template inside Medini. So here, just a short description of how we deal with the cybersecurity. Of course, you want to create a new project for the cybersecurity. As you can see here, we have directly in the template, in the proposal, the template inside Medini, you can easily give a name for your project and then select directly the cybersecurity template. Of course, this cybersecurity template is a proposal, again, from our side, as far as for safety, according to ISO or different standards. You can also customize these templates according to your needs. Here, if we go deeper down, we created a project, and then we have to define the architecture. In the context establishment, we need to define the architecture. So from the palette, again, you can easily drag and drop and create a specific or what do you need exactly to create the architecture. Or you can import from external tool the architecture for the cybersecurity part. When you have the architecture, then for each subsystem component, you have this possibility to assign assets. Of course, you need to go in the security part and then select assets. And these are the security attributes for the moment that we propose inside Medini: confidentiality, integrity, availability, etc., that you can select for a specific component. Of course, these cybersecurity attributes are customizable. I mean, you can easily customize these security attributes for the aerospace, for the, let's say, railway or automotive. When you have your architecture, then you define the assets. Then from your architecture, you can generate the table for the traits, where you can define the traits. So if we go deeper down, how does it look like, the traits table? Of course, you have the ID of the component, the name of the component, the assets, then the categories, of course, according to the ISO, we have five parameters where you are going to define the risk level: equipment, expertise, knowledge, window of opportunity. Then you can easily define these 4 parameters and define the risk level. When you're done with your trait identification, of course, then you can also have the attack collection. Of course, this attack collection you can create directly inside Medini that we support. I mean, creating from scratch directly the attack collection. Or otherwise, if you have an attack collection and an Excel sheet, you can also import your complete attacks inside Medini. And of course, again, for the attacks, when you're going to have your attacks, for each specific line of your attacks, you're going to define the likelihood level, expertise, knowledge, and window to define the likelihood level for your attacks. When you have your attacks here, as you can see, screenshot of this table. At the end, you have the likelihood level. Of course, you can easily add. You have this option, as you can see on the right, plus option, where you can add lines. You can also generate, if you want to generate directly a report from Medini for your attack collection. So you have also this option, as you can see next to the printer. You can also generate the report. When you're done with your, of course, the attacks, I mean, you define your attacks, then you have to do the attack trees. And of course, the input that you need for the attack trees is the traits. Then from your attacks, you're going to drag and drop to create or to build your attack trees. Of course, as you can see on the left, we have the palette where you can also drag and drop to create gates, OR gates, AND gates, voting gates, and also basic event that you can create. And from this, on the left, on the model browser, you have your list of attack where you can drag and drop also to build your attack trees. When you're finished with your attack trees, of course, when you're finished, then you need to calculate the attack paths. And in Medini, we support also right-click on the top level of your attack tree, and then right-click and click to calculate the attack paths. When you have your attack paths, of course, then the end that you need to fulfill all this information is the risk assessment. And of course, for the risk assessment, you need to define the safety impact, financial impact, operational impact, to define directly the risk level. So it's a screenshot of the risk assessment and risk treatment table that we support inside Medini. As you can see, you have your assets, you have your trades, and then you have to define the safety impact, financial, operational impacts, and then of course justify. Here we of course the end is to define the likelihood level for the trade scenario. The end, when you're done with your risk assessment and treatment, after that, if your risk is very high, the security level is very high, then you have to again define some measures, to put some measures, some mitigations or treatment option that we support on site Medini. You can select from the threat option, mitigation, avoidance, etc., and put measures. We also support in Medini a list of measures where you can define your measures and put for each of your traits. And of course, as you can see, the output of this table is the security goal. And we support also this security goal inside Medini. So we have now, with the new version of Medini, Medini version 2021 R2, we support also cybersecurity goals inside Medini. Okay, reports. As I mentioned to you, if you want to generate for safety or for the cybersecurity, you can generate, of course, custom reports. And for this, you need to use the extension that we have inside Medini, birds, where you can, of course, customize according to your needs. Have your logo of your company, who is working on this project, the summary, etc. So you can easily customize by using bird to customize your template, or you can also generate standard reports that we support inside Medini to generate standard reports for each of your work product, or generate a project reports, standard project report from Medini. So now we are going to live demo in Medini, of course. As you can see, we have, let me share my screen. So I hope you can see my screen. Here we have, of course, a lot of projects for different customers. As you can see, according to the aerospace, we have a project, done with all the analysis according to the ARP 4761A. We have an example here, system break. We have another project in the automotive, which is the ESL example. We have another project for the industry domain according to 61508. We have the cybersecurity project according to the DO 356. Of course, we have another project to do our safety analysis on the battery management. And for the tier 2 and tier 1 and tier 2, we also have a complete project inside Medini, and this project called microcontroller, where you have to define, you need your architecture, then you have to do your FMEDA analysis and to define the single point fault and late point fault. So as you can see, we have different customers, and for each sector, we have different examples that we can share with our customers, and they can look on it and how we deal with different standards to do the different analysis inside Medini. Of course, I have no time to go deeper down in each of one. I will take one of this example, which is in the ESL example in the automotive domain. As you can see here, if I open this ESL example, electronic string lock. When you're doing your safety analysis, the first point that you need is the safety plan. And of course, how we deal with the safety plan, what we propose inside Medini for the safety plan is the task list that we propose inside Medini. For example, if you're doing the functional safety concept, you need to have the functional safety concept tasks according to the ISO 26262. So here, as you can see, if I go deeper down, if I open the task list that we have inside Medini according to the ISO 26262, you need to specify the item, then you have to define the describe the item, define the functions, supporting functions, etc., etc. So all these tasks or the topic that you can see is according to the ISO 26262. Of course, we have the same task list for the military. For example, according to the MIL STD 88-2E. Same for the aerospace for the safety part. Same for the cybersecurity and the aerospace part. So important thing is why we use task lists. We have a column called related element, which is the artifact. That means we are going to have the traces between our task list and our safety analysis. In this case, for example, if I want to see if I done this item description in my project, so here in the related element, I can see that yes, I did the description of my item, and here we have a related element, which is the item description, electronic string log. And from here, if I right click, if I go show element in browser, so Medini will put directly where this item is inside. Of course, according to the ISO, it's under item definition. If I double click then on the item, so here you have the name of your item, which is the electronic string log. You have, you can also give a complete description of your ESL, additional here additional table that we have, of course, for the item description according to ISO. If there is any legal requirement, of course, if there is any operational and environment constraint, additional specification, etc., etc. So you can easily customize also this item description according to your needs. When you're done with the item description, then according to ISO, you have to define the functions. Of course, inside the item description, you have to define the function inside Medini. We support, of course, you can also customize. We have the vehicle level function. For example, in my case, on the electronic string log, we have the function A1, which is log string, and function 2, which is unlock string at the vehicle level. And at the supporting level, we have also functions. We can have also functions. For example, in my case, for my system is detect ignition status. So according to ISO, you need to define your item, then you have to define the functions. And then according to ISO, you have to also define the preliminary architecture or an abstract architecture. Of course, we are not going deeper down. As I mentioned to you, we support the CCML language 1.4, where you can create or build directly your architecture from this palette, so you can easily drag and drop to create the architecture. You have also this possibility, if you don't want to create this abstract architecture, and if you have any preliminary architecture at in Magic Draw or in Rhapsody, you have also this possibility to right click on item definition, right click and go to import. And these are the possibility or the integration that we have to import your architecture. Magic Draw, Rhapsody, Enterprise Architect, sorry, and from IP design model. Of course, these are for the tier 2 for the microcontroller, etc. that they want to import also their failure rates inside Medini. So we have also this possibility. You have your abstract architecture, and then according to ISO, you're finished with the item definition part. Now you have to jump in the hazard analysis and risk assessment. Of course, here we have hazard analysis and risk assessment. If you want to create a new hazard, then right click on the package, create a new hazard. In my case, I'm not going to create a hazard because I already have a hazard here, hazard analysis and risk assessment table. So I can double click. I can see the table that I have for the hazard analysis and risk assessment. Of course, the input that we need from the item definition part, we need the functions. And then when we have the functions, we need to define the malfunctions. And of course, in Medini, we support also HAZOP methodology or guide word analysis, where you can define your malfunctions according to the keywords. For example, in my case, if I open these element, which is the functions, these functions are coming from the item definition. I can easily drag and drop this function, for example, here inside the item, and then create an empty line. And according to HAZOP methodology, we have here some guide words where you can define easily your malfunctions. For example, lock string, no or not. Okay, the malfunction is lock not activated when required. More, lock too strong. So this, by using this guide word analysis, we can easily define our malfunction. Later on, when we are finished, we can come back to our hazard analysis and risk assessment. And here, easily, we can, for example, pick up a malfunction, drag and drop this malfunction, because I want to create a specific line in the HARA for this specific malfunction in the HARA. I can just drag and drop. I have this possibility to select and create a new line, an empty line, or I have also this possibility to combine the malfunctions with the selected situation catalog. I mean, in Medini, we also support the VDA catalog for driving situation. So you can also combine this driving your malfunction with the driving situation that we support. And of course, the catalog that we support, you can easily combine this one. And if you say okay, then you're going to create 3 new lines where you are going to define. Of course, you have the malfunction, you have the functions. You don't need to focus on the driving situation because you use the VDA catalog or the standard catalog that we support inside Medini, basic driving situation, for where you have where they define the explorer. So you can easily select this one, and as you can see, you have already driving situation here in place, and then you have to define the hazards. And of course, if you have a list of hazards, you need to select from this list of hazard, double click on it, select the hazard here. Okay, and of course, if you have a list of hazard and you want to import the list of hazard inside Medini, so you have also this ability to import from Excel import the list of your hazard directly inside Medini in the hazard table. And later on, then you're going to define, of course, selecting the hazard, the specific hazard for this specific line. Then you have to define the potential failure, effect, etc. You have to define this 3 parameters, which is severity, exposure, and controllability, and then Medini will calculate automatically the SL level. Of course, I don't have much time. I can not go deeper down, but here you have the list, the hazard table. Of course, as I mentioned to you, you can easily right click and go to rename a column where you can rename a column. If you have any additional column, then you can also add new columns. And of course, these columns are a proposal from our side. For example, you're not using potential effect or accident type, then you can simply uncheck the columns for your HARA. When you have your HARA, of course, then the output of the HARA is the safety goal. For example, if I define my level of severity, and of course you have to justify why you choose S2. Here the exposure is already done because we choose the driving situation catalog that we have inside Medini, and then we have to define the exposure. Of course, why you choose C3, you have to justify, and as you can see, you're going to have directly the AC level, and later on here you can double click here. If you have a list of safety goal, you can select from this list of safety goal to put in the specific line of HARA. Otherwise, you are also, you can also create a new safety goal. If you don't have in this list, you can create a safety goal directly inside Medini for this specific line of HARA. Of course, you have your HARA here, and then you have the safety goal, and of course the safety goal is the input for the functional safety concept. So we have here a package for the functional safety concept. As you can see, we have a list of requirements, but before having all these functional requirements, the input that we need is the functional architecture. So as you can see in the architecture model, we are going deeper down. At the item definition, we have the abstract level. Here we have the functional architecture. You have to create this functional architecture inside Medini or import. When you're done with the functional architecture, then you can easily right click and generate a new FMEA worksheet. You can easily generate a worksheet here for your functional architecture. I'm not going to create because I have already a functional FMEA, sorry, here for the functional safety concept FMEA. So you can see here, according to the new standard, if you're using the new standard, then you have to select a VDA AAG. It depends. If you want to calculate the risk priority number, then please select this columns. Action priority according to the new standards, supplementary FME for monitoring and systems. And then if you come back to your FME worksheet, as you can see here, we have the complete FMEA table, and all these component functions are coming from our architecture. And later on, each engineers need to define, of course, the potential failure effects at the functional safety concept level. Later on, if we go deeper down in the technical safety architecture, so of course, for the technical safety architecture, we are going to create a deep down component architecture. Here in Medini, you have this possibility to create this technical architecture, and then when you're finished with your technical architecture, right click and derive a new FMEA worksheet for the technical one. And of course, how does it look like? The technical safety concept FMEA. Again, if we go from in the worksheet, as you can see, we are going deeper down. And in this case, you have, of course, the name of component, subcomponent, etc. You have to define the failure modes here, failure effects, and then according to the new standard or the previous standard, you have to define the action, detection action, prevention action here, and then you have the action priority, which is calculated automatically here.
Abdul, I have to interrupt you because we are running out of time a bit, and we also have quite some questions already in the chat box. So I would suggest that we move on to the next part and then go to the questions. Is that okay with you?
Yes.
Okay,
yes.
Very good.
Yeah, we can go because yeah, the more important thing was the technical one. I'm done.
That's very great. So thanks for, sorry to interrupt you, but we have some questions in the chat box which we also like to answer for the audience. But first of all, let me summarize what we have seen so far. So by giving you the overview by Nikhil and the demo by Abdul, there we go. Yeah, the way I like to summarize this is that we can actually help you. So we can have a look at all your different goals. If it is more like strategic, like more from the compliance side, or communication, collaboration, or if you are focusing, maybe you're in a more technical role. So also your technical goals, we can help you out there. Yeah. We just not do that like only with the technology and the training, but we can also organize a workshop, for instance. So we can sit together with the different disciplines and start having the conversation, a workshop, yeah, to find out like what is the best solution for your functional safety and your cybersecurity challenges. And also, of course, on the business or economical goals, yeah, we can also with the technology that is available today on the Medini Analyze, yeah, we can also have a higher goal, yeah, so to reduce the time that you spend, so and especially on the cost side, so can actually be reduced by 57%, but also so you will have your products quicker available to launch it in the market. So as I've shown at the very beginning in my introduction, there was a top 10 in 2019, and this is specifically about cybersecurity. And I must mention, like, this is a broad approach, but I would like to show you how it changed in the last, in 2020. So the order already, switched significantly. So you see here at the bottom, education, media, healthcare, and we go all the way up to the top. And now you see that number one is still finance and insurance, but now also manufacturing and energy is quite high. Yeah, so this is one of the reasons that we also addressing the topic, like the shift on this, like on cybersecurity, is there. It will be on. It is a great focus, of course, like from that part. So my main message is like, put your cybersecurity and also your functional safety high in the agenda within the business goals that you try to achieve. No, I have to click. Okay. Then I would like to, there we are. Also an announcement from our side. So Ansys is organizing a conference about digital safety. It's going to be at the end of this month, 26, 27. You can subscribe, it's completely free. And we will also communicate a link of it to you. So if you're interested and like to have a closer look, then please feel free to participate within this event. Also, I'd like to take a moment to thank Nikhil Kelkar and Abdul Nias of Ansys to tell you more about Medini Analyze and the technical, but also the aspects of how you can manage it within your company from a functional safety point of view. So thanks for you guys. And then we're getting at the end. So I'd like to open the floor for questions. And when I'm sure, so we already have some questions available.
Yes,
Anna, could you please take over?
Yes, I will take over. Thank you all. Thank you, Nikhil, Abdul, and Jeroen for presenting this nice webinar. There are some questions. The first one is, does Ansys Medini allow formal description of functional safety requirements? I will you all unmute.
Yes, if I answer yes, we have a specific table here inside Medini where you can describe your functional safety requirement inside Medini.
Okay, thank you, Abdul. The next question, how does one translate on ISO 26262 ASIL into the mechanical scope? For example, if you have targets of ASIL B, how does this translate to a mechanical metric? Is there some standard for this?
Well, for the mechanical part, we do support the to calculate the failure rates for a component. Okay, for a specific component, we do support for the hardware part to calculate directly the failure rate of a component according to the standard. And the standard that we support is the NPRD to calculate directly the failure rates for a mechanical component. But if you want to transform the ASIL-B into a matrix for mechanical part, then we have also the possibility to do some scripting column inside Medini. In a JavaScript, we can customize where they can calculate or directly if you have the AC level in a matrix for the mechanical part, yes.
Okay, thank you. Another question. Is it possible to combine the safety and cybersecurity analysis in the same model, assuming that
Yes.
some threats have an influence on the safety?
Yes, we have customers using, and we have inside Medini with the new version of Medini, we have a template where you have the combination between the safety and cybersecurity. And of course, we know that when you're doing the safety analysis, the input that's coming from the safety is the hazard list. Of course, yes. So the answer is yes, we have a template for specific for cyber and safety in Medini.
Okay, that were the questions already put in a text panel. Are there other questions?
There was one more question, Arna, which was just before that, the ISO 9001N.
Let me see. Thank you, Nikhil, for. Let me see. Can you maybe? You put this one? Let me see.
So maybe I can ask this.
Yeah, can you?
It talks about,
because I can.
Yeah. So it is ISO 9001 plus ISO 26262 gives, in my opinion, a very complete definition. What do you need to do for hardware and software development? What would ASPICE add to this? As ASPICE defines maturity level, and ISO 26262 just tells you what to do for ISIL. So maybe Abdul, do you want to talk about ASPICE in here?
Well, if we talk according to ISO 901, it's really related to the quality, right?
Mm-hmm.
For the quality part, of course, as I showed in the demo, according to the ISO, you need to do your different tasks according to the ISO. So we support, of course, these tasks directly inside Medini. Functional safety concept, technical safety concept, for the hardware safety concept, and software safety concept. So we support all these tasks according to ISO inside Medini. And of course, later on, you can also customize if you want to add some more input according to the quality, ISO 9001.
Okay.
And I want to add one more thing according to ISO 9001 quality. We have a new version of Medini, of course, that is available, what we call DSM, Digital Safety Manager. And of course, in this Digital Safety Manager, according to the quality department, you can, of course, define the planning, who are the person that are working in this project, and you can see also the maturity of the project inside Medini if we use the DSM, Digital Safety Manager. And of course, this Digital Safety Managers is just a, let's say, a kind of management level for managers to see the project's evolution during the time.
Okay. I think regarding to the time slot, we are going to close this webinar. For sure, I will send you the thank you mail with all the necessary input, like a trial, but also the PDF presentation, of course, and the recording. And if we skip some questions, we come back to you, no problem. First of all, thank you for the presenters and the guest speakers, Nikhil and Abdul. Thank you very much. And thank you everyone for attending this webinar. On behalf of Ansys, Nikhil and Abdul and team of Infinite, we thank you for joining us this afternoon and wishing you a nice day. Thank you very much. Bye-bye.